So let me tell you the basic concept for finding the time complexity. We assume that every statement in a program takes 1 unit of time for execution. Let me give you the idea behind that one. See, suppose there are some books kept here and you have to move the book and keep it in a shelf or in a rack. How much time it takes? Maybe half a second, quarter of a second. Now, for somebody who walks very slowly, may take 1 second for keeping one book there, one by one if you have to keep. So, time varies from person to person. So, we don't mention seconds or milliseconds, we say 1 unit of time. Like if you take the example of currency, $1, 1 rupee, 1 pound. So, we say 1. But what is the market value? That may be different. So we say $1 or 1 unit of currency. So same way, we assume that every statement takes 1 unit of time. If that statement is repeated multiple times, then you count the frequency, how many times it is executed. So that is sufficient for analyzing our function now. Let us see what our function is doing. It's doing nothing, just printing. So it is printing a value of n. How much time it takes for printing? 1 unit of time. 1 unit of time. How many times printf is written here? Only one time. So it is just 1. But this is a recursive function. So it is calling itself again and again. So total how many times it is printing? So let us look at into the tracing tree or recursion tree. Here it is printing 1 time, 2 times, 3 times. So total how many units? 1, 1, 1. So I can say it takes 3 units of time for the value of n as 3. Value of n as 3. So the first value of n is 3. If I make it as 5, then it will take 5 units of time. Then for n, it will take n units of time. So it is just like, coming back to the example, if you have to keep one book in the rack, you are taking 1 unit of time. 10 books, 10 unit of time. N books, n unit of time. What is n? Whatever may be. So the time depends on the number of books. So here the time depends on the value that you are passing from here. It may be 3, it may be 5, or it can be anything. So we say the time taken is n units of time. So the time can be represented as order of n. The answer that we got is n units, so the degree of that polynomial is 1, so we write it as order of n. So the time taken is order of n. There is one more method of finding the time complexity using recurrence relation. I will show you how to write recurrence relation and how to solve it to find the time complexity of recursive functions. Now let us find out the time complexity of this recursive function using recurrence relation. We assume that the time taken by this function is t of n. T is for time. If the time taken by that function fun1 is tn, then that total time should be sum of all the times taken by the statements inside. So let us look at the statement. See, there is a statement. This is a conditional statement. How much time it takes for execution? Just 1 unit of time. 1. Then there is a printf statement. How much time it takes? This also takes 1. Then there is one more function call. How much time it takes? 1. As I said, every statement takes 1 unit of time for execution. So this also I have written 1. No, it's wrong. It's wrong. See, that is a function call. So I should know total time taken by that function call. So it is not just a normal statement. It will call again itself, so there is something more behind that one. So I need to know how much time that function call is taking. So let us see closely. When I said this function call total time tn, then this is similar to that one, and this is n minus 1. So yes, this will be taking tn minus 1 time. Yes, this is not a normal statement. There is a function call and it takes tn minus 1 time. Then what is this total tn? I said the sum of all the times taken by the statement. So let's take the sum. So that tn is equals to Tn minus 1, the bigger term I am writing first, plus 2, plus 2. So the total time is Tn is equals to Tn minus 1 plus 2. So the recurrence relation is Tn is equals to Tn minus 1 plus 2 when n is greater than 0. When n is greater than 0. What happens when n is equal to 0? When n is equals to 0, it will just check the condition, it will not enter inside and it will come out. So just checking the condition, 1 unit of time. So it takes 1 unit of time. So this is the recurrence relation formed from that function. So the time complexity of recursive function can be represented in the form of a recurrence relation. Now if we solve this using induction method, or also called as successive substitution method, we can get the answer. So let us solve this one. Now before solving this, I should tell you one thing. If you have any constant value here, then let us write it as 1. So that means constant. Now let us solve this. So the recurrence relation is a Tn is equals to Tn minus 1 plus 1. This is the first equation we have. I can solve this if I can know what is the Tn minus 1. See, here I write, since Tn is equal to Tn minus 1 plus 1, then what will be Tn minus 1? So if this is n, replace with n minus 1, so this will be Tn minus 2 plus 1. So I can substitute this one, Tn minus 2 plus 1, in place of Tn minus 1. So this I can replace here. So the next equation that I get is Tn is equals to 2Tn minus 1, Tn minus 2 plus 1. So this is Tn minus 2 plus 1, and this plus 1 as it is. So this is substituted with this one, and then this plus 1 as it is. So what is this one finally? Tn is equals to Tn minus 2 plus 2. So let us call this as second equation. Then let us substitute in this place. So what this will be? This will be Tn minus 3 plus 1. So if I substitute that, then this will be Tn is equals to Tn minus 3 plus 1 and plus 2. So this can be written as Tn is equals to Tn minus 3 plus 3. This is the third equation. So I have substituted 2 times. How long I should do this? Let us continue it for k times. So k times Tn minus k plus k. Because this was 3, so this is also 3. If it is 4, then this will be 4. If this is k, then this will also be k. So the fourth equation I got. See, we have to solve this one. So substitute, and then substitute, then substitute, go on substituting until it reduces down to a smaller value, that is n equal to 0, where we know the answer, that is 1. See, when you don't know the answer for a bigger expression, you know the answer for a smaller expression, then break the bigger one into smaller one and solve it. So the same thing we have done. We don't know how much this is, but we know when n is equals to 0, answer is directly 1. So we know that. So we have tried to reduce this and by substituting, and we got this one. Now we say that this n minus k actually has become 0. So on that side I will write down, assume that n minus k is equals to 0. So it means we have n minus 1, that we made it as n minus 2, then n minus 3, and so on, up to what? It became 0. So we assume that this has become 0. So it means, therefore, n is equals to k. So in this equation, if I substitute, that will be Tn is equals to Tn minus n plus n. So at the place of k, I have written n. So n minus n plus n. So I got this one. So this is Tn is equals to T0 plus n. So Tn is equals to 1 plus n. So that's all. I got the answer. Tn is equals to 1 plus n. This can be written as order of n. See, earlier, directly from the tracing tree also I have shown you n plus 1 was number of calls. So yes, I got the number of calls here. And the time taken by this function depends on the number of calls. So yes, it is order of n. So it will be printing for n times and the calls will be n plus 1. That is one more than the number of times of printing. Let us summarize the things that we have learned. See, I have shown you what does it mean by recursion, and I have shown you how to write a recursion. I have traced that one, and I have shown you two different type of recursion. Then I have shown you how a stack utilized, and then we saw how to find the time complexity. From the tree also I have shown you, and by writing a recurrence relation also I have shown you. And the time complexity is mostly written as order of or degree of, that is order of n. See, I'm not using the notations like big O, omega or theta because we have not discussed about them. So I'll give you the idea about these notations at some other time.